All right, let's look at the homework 16.8, problem number 5. All right, so we need to find the first curl of vector field F. All right, so this is going to be equal to, all right, so here's I, J, K, partial with respect to X, and the partial with respect to Y, and the partial with respect to Z. Right, so X component is Z squared, and the Y component is 5XY, and the Z component is 2Y squared. Right, so this is going to give us, let's see, so first component is partial with respect to Y, so that's going to be 4Y minus 0. All right, second component is going to be 2Z minus 0. And the Z component is going to be 5Y minus 0. So it's just going to be 5Y. All right, so we have that. All right, so let's look at this path. I'm going to just draw a picture here. So you have here's the x-axis, and here is the y-axis, and here's the z-axis, right? And here's the origin, right? So we're going to start from the origin. So we're going to go from here, right? Then we're going to go to 1, 0, 0, which is right here. So we're going to move here, right? So we're going to move from here to there, right? Then you have a 1, 4, 1. So which is going to be, let's see, y is 4 there. Then we go here and here 1, 4, so we're gonna go up 1 unit. So we're gonna have a point here, right? So we're gonna go straight to there. Then we're going to go to 0, 4, 1. So x is 0 and the y is 4, 1. So it's going to be up there. Right? So it's going to go there and then close the box there. Right? So this is the surface there. So we have this surface right here. All right, so let's try to find the equation for this plane. So we have a vector there. So this is a vector. So this is just a 1, 0, 0. So that's just a vector I. So here, x component is 0, y component is 4, and z component is 1. Right, so we can find the normal vector by taking the cross product between those two guys. So I'm going to take the cross product between 1, 0, 0, and cross with 0, 4, 1. Right, so what's that? So it's going to be I, J, K, and you have a 1, 0, 0. 0, 4, 1. Right, so this is going to be equal to, right, so first component is going to be 0. Right, second component is 0 minus 1, so it's a negative 1. And the last component is going to be, let's see, 4 minus 0, so it's going to be 4. Right. So the equation of this plane is going to be negative y, right? Because 0 times x, negative y, and the plus 4z equal to 0, right? which gives us the equation z is equal to y over 4. Alright, so we have this parameterization R, which is going to be, we can just use x and comma y comma z is y over 4. Alright, so we can do R with partial with respect to x, cross product R, partial with respect to y, which is going to be vector I, vector j, vector k. Alright, so partial with respect to x is going to be 1, 0, 0. Partial with respect to y would be 0, 1, 1/4. Alright, so this is going to give us, so cross product. Alright, first component is 0. Alright, the second component is negative 1/4. And then last component is going to be 1. Alright, so we can turn this integral into, so we have a work would be integral. Alright, so you have, so we're trying to compute, so the pass is C, and then you have vector F dotted with dr, right? So by Stokes Theorem, so using Stokes Theorem, right, we can rewrite it as a double integral over this surface S. So this is the surface S, so over S here. Right, then we take the curl of this vector field F, and then dot it with ds vector. Right, so we can compute this. This is going to be equal to, right, so you have a double integral. Right, now we have cross product is already computed somewhere, yep, so you have a 4y, 4y, comma, right, 2z, remember that z is equal to, let's see, z is equal to y over 4, so I'm going to plug it in. 2 times y over 4 is y over 2, right, and you have a 5y, right. Then we take the dot product with this guy, so you have 0, comma, negative 1/4, comma, 1. And then this is going to be a dA, but I'm going to just go ahead and dx and dy, right? So if you look at the region D, which is going to be on the xy plane, so the region D is right here. So here's a D, so which is just a rectangular region sitting right below the surface. So you can see that the x is going from 0 to 1. So x is going from 0 to 1. And y is going from 0 to 4. So 0 to 4. Right, so let's evaluate that. So you have a double integral 0 to 4 and 0 to 1. Right, this times that is 0, so minus y over 8 and plus 5y. Right, dx, dy. Right, so what's this? So this is going to be 5 is the same thing as 40 over 8. You have 1 minus 1 over 8. So you have a 39 over 8y. Right, so I'm going to separate this. Right, so it has nothing to do with x. So we have x is just from 0 to 1 dx. Multiply by, all right, so y part, so antiderivative would be 39 over 8. Antiderivative y would be y squared over 2. Then you're going from 0 to 4, right? So this is going to be, all right, integral from 0 to 1, so this is going to be 1 anyway, so it's that. Right, if you plug in 4, so you have a 4 squared is 16, that will cancel. You have a 39 minus if you plug in 0, it's 0. So this is going to be simply 39. Right? So let's type it in. Oops. Alright, so the answer we got was 39. Let's check the answer. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.